Very good morning, dear children. Let us start our today's class with a prayer. God, grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, I am very happy to meet you to teach you science for your class, and I hope you also enjoy my class. And if you have any doubt regarding science, you can call me personally. If you couldn't understand any topic which I am going to teach you in every video, you can ask your doubt without hesitation personally to my WhatsApp number. I will there to help you. Teachers are there always to help you only, so don't hesitate. Okay. uh, Whenever I find time, I will clarify your doubt. Let's enter into the lesson. In your science you have 25 lessons. First 9 lessons are in physics. So the first lesson is measurement. In this lesson measurement, you are going to understand the fundamental and derived quantities and their units, and you come to know the rules to be followed while expressing physical quantities in SI units, and you get familiar with the usage of scientific notations. These are all the objectives we are going to achieve in this video. So, to introduce you, what is measurement? Measurement is the basis of all important scientific study. In our day-to-day life, we are measuring many things. If you want to know the height of your sibling, you measure. If you buy some milk from milkman, you have a measurement: 1 liter milk, half a liter milk, you ask like this. Okay. You go for shopping and buy some dress material. What will you ask? 2.5 meters of this cloth, 1.5 meters of this cloth. The saree length is 5.5 meters without blouse. With blouse means it is of 6 meters. Okay. So everything we need measurement. For everything we need measurement. So how can we determine measurement? It is defined as the determination of the size or magnitude of a quantity. I repeat, it is determined or defined as the determination of the size or magnitude of a quantity. So in this lesson you will learn about units of measurements and the characteristics of measuring instruments. So let's know physical quantities can be classified into two types. One is fundamental quantities, another one is derived quantity. You can classify the physical quantity as fundamental quantity and derived quantity. You can classify the physical quantity as fundamental quantity and derived quantities. What are fundamental quantities? The quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities. I repeat, the quantities which cannot be expressed in terms of any other physical quantities are known as fundamental quantities. Examples: length, mass, time, temperature, etc. For suppose you may ask me, ma'am, I measure length using a scale. I have a scale and I can measure the length of my pen or pencil. Then how can you say the length cannot be measured by any other physical quantity? Yes, the scale is a measuring device. It is an instrument. Instrument cannot be a quantity. Length is the fundamental quantity. You cannot measure any other thing. You cannot measure length using any other thing. For suppose I would like to find out the area of a square. So area is another quantity. So I want to find out the area of this square. What I have to do? I have to measure the length of one side, that is considered as A. So I have a formula, A square, to find out the area. So to find out the area, A is equal to A square. So I measure one length and length square is equal to area. So using length is a fundamental quantity, I can find out the area, another quantity. Area is another quantity. So it is called as derived quantity. Quantities which can be represented in terms of fundamental quantities are called derived quantities. Quantities which can be expressed in terms of fundamental quantities are called as derived quantities. Example area, volume, density. So this table you will find out later. Now, what are units? Unit is a standard quantity with which the known quantities are compared. I repeat, unit is a standard quantity with which the known quantities are compared. So, it is defined as a specific magnitude of a physical quantity that has been adopted by law or convention. For example, I ask you to measure the length of your pencil. You measured and tell me that it is 12 centimeter. So you take a scale, take your pencil and measure the length of the pencil and you will say 12 centimeter. 12 is magnitude, the number is magnitude and centimeter is its unit. So what is the meaning of 12 centimeter? It is 12 times that of 1 centimeter. 12 times that of 1 centimeter. So in different places, different countries, different systems of units were used. So there is a possibility for a confusion. For example, see table 1.1. The table 1.1 shows you units of systems used in earlier times. First, CGS system has been given. CGS system, in CGS system, length is measured in centimeter, mass is measured in gram and time is measured in second. This CGS system is followed in German and it was found by a scientist named Gauss. The another name for CGS system is Gaussian system. So the another name for CGS system is Gaussian system, as the inventor name is Gauss. Okay. And FPS system. FPS system, the length is measured in foot and mass in pounds, time in seconds. It is followed by British people. So in European countries itself, German is an European country, British is an European country. So among the European countries itself, different systems were followed. In India, what are the systems we follow? You ask your grandfather distance between two villages. He used to say this much mile. This much mile. எங்கள் தாத்தா சொல்கிறார் இத்தனை காத தூரம் போனோம் அப்படின்னு சொல்லுவாங்க. காத தூரம்னா என்னன்னு எனக்கு இது வரைக்கும் தெரியாது. So காத தூரம், mile, like that our grandfathers will say. But we don't know what is mile. How can we express mile? So there is a requirement for a uniform unit for the systems. So at the end of the Second World War, there was a necessity to use worldwide system of unit. So in 1960, international systems of unit is derived in the General Conference on Weights and Measurements at Paris. So that provides us SI systems of unit. SI system of unit is the modernized and improved form of previous system of units. It is accepted in almost all the countries. It is based on the certain set of fundamental units from which derived units are obtained by proper combination. So here table 1.2 shows you fundamental quantities and their respective SI units and its symbol. So what is fundamental unit? We know fundamental quantity. So what is fundamental unit? The units used to measure fundamental quantities are called fundamental units. I repeat, fundamental quantity is different, fundamental unit is different. The definition for fundamental quantities is in page number 1. The definition for fundamental unit is in page number 2. The units used to measure the fundamental quantities are called fundamental units, and the unit which are used to measure the derived quantities are called derived units. So table 1.2 gives you the fundamental quantity. There are 7 fundamental quantities, namely length, mass, time, temperature, electric current, luminous intensity, amount of substance. The definition, everything and all you might have learnt in your earlier classes. I have taught you. So in your 9th standard, you again in this lesson got a recollection. That's all. Okay. With the help of these 7 fundamental units, the units for other derived quantities are obtained. So let's see the unit for this fundamental quantity. Length, fundamental unit is meter. Mass, fundamental unit is kilogram and its symbol is kg. Time, the fundamental unit is second, symbol is S. For temperature, the fundamental unit is Kelvin, symbol is capital K. Electric current, the fundamental unit is ampere and its symbol is capital A. For luminous intensity, fundamental unit is candela, its symbol is Cd. Amount of substance is measured in mole and its symbol is MOL. Okay, let's see the derived quantity. See, this is a short list of derived quantity. There are numerous derived quantities are there. Area, volume, density, velocity, momentum, acceleration, force, pressure, energy, surface tension. These are all the few derived quantities. Let's see the expression for that, because if we know the expression, then only it is easy for us to find out the unit. You need not to memorize the unit. If you just learn the expression will help you to find out the unit. I will guide you. Okay, see, area expression is length into breadth. If it is a square, breadth, length both are equal, so length into length for square. But for any rectangle means length into breadth. So length, for length you write A, and for breadth you write A. So A means side, length of the side, its unit is meter, and its unit is meter, and meter into meter, meter square is the unit for area, derived unit for area. Okay, I hope you understand. I repeat with another example. Volume means area into height. Volume means it is a three-dimensional view only. So it will have length, breadth and height. It will have length, breadth and height. So three things. So what is the formula for volume? Area into height. For area we have unit as meter square. For height we have unit meter. So what is the formula for, what is the unit for volume? Meter cube. Meter cube is the unit for volume. Dear students, you please don't just watch the video using your mobile. You have the book with you. Whenever you see the video, you take your book and always follow the book. And wherever you don't get my point, you just pause the video and read the book again, and you will catch the point. If you couldn't catch my point, you just rewind the video and listen to my explanation again and again. It will very easy for you, because there is a convenience in this online class that in class you cannot rewind me, but in this online you can rewind my audio. Okay, if you couldn't catch my point, you can rewind that particular point alone and you listen to my audio repeatedly, and it will be very clear. Okay, and let's see the example with the third one, density. For density the unit is the expression is mass into mass divided by volume. Mass divided by volume. So for mass we have fundamental quantity. Mass is a fundamental quantity. The unit for mass is kilogram. Volume previously we find that meter cube. So kilogram divided by meter cube is the derived unit for density as shown in the table here. Okay. Next, velocity. Displacement by time. What is displacement? Displacement is nothing but distance between 2 points. Displacement is nothing but distance between 2 points is displacement. So how can you measure this distance? Using a scale. So it is nothing but length. So for displacement the unit is meter. For time the unit is second. That is a division. If anything is in division, you can put that expression into numerator using a minus power rising. Okay, so meter second power minus 1. Meter second power minus 1. Next, momentum. For momentum, mass per velocity. For momentum, the expression is mass per velocity. Mass, you have the unit is kilogram. It is a fundamental unit. And velocity, just now we have seen. So mass into velocity, kilogram into meter second power minus 1. Okay, like that you can find out the remaining. Using remaining expression you can find out the units for the remaining things. Okay, next we move on to length. Fundamental value, length. Length is the extent of something between 2 points. The SI unit of length is meter. So let's define the unit of length. Length, definition for length is different. Definition for unit of length is different. Definition for length is the extent of something between 2 points. Okay. Definition of unit of length is, what is the unit of length? Meter. You need to derive meter. Okay, there will be a question, define the unit of length. For that you have to answer, the unit of length is meter. 1 meter is the distance travelled by the light through vacuum in 1 divided by 29 crores 97 lakhs 92,458 second அப்படின்னு சொல்லணும். Okay, that is the definition for length. I repeat the definition. 1 meter is the distance travelled by the light through vacuum in 1 divided by 29 crores 97 lakh 92,458 second. So in order to measure very large distance, so this length we can measure in this earth, very large distances. For example, if you want to measure the distance between sun and earth, want to measure the distance between sun and moon, earth and moon, the distance between different planets, we just need not, the meter and kilometer will not help us. So for that, to measure large distances, certain things are used. What are they? Astronomical units, light year, parsec. Astronomical unit, light year, parsec. Let's find out the definition for each things. First one is astronomical unit. It is the mean distance of the center of the sun from the center of the earth. So in your diagram they have explained clearly, mean distance from the center of the sun to the center of the earth. So the one astronomical unit is equal to 1.496 × 10 to the power 11 meter. Next we move on to light year. What is light year? It is the distance travelled by the light in 1 year in vacuum, and it is equal to 9.46 × 10 to the power 15 meter. I repeat, it is the distance travelled by the light in 1 year in vacuum, and it is equal to 9.46 × 10 to the power 15 meter. What is a parsec? Parsec is the unit of distance used to measure astronomical objects outside the solar system. So 1 parsec is equal to 3.26 light years. So the larger units and its value in meters has been given in table 1.4. For kilometer, it is equal to 10 to the power 3 meter. Astronomical unit 1.496 × 10 to the power 11 meter. Light year 9.46 × 10 to the power 15 meters. Parsec is equal to 3.08 × 10 to the power 16 meters, which is equal to 3.26 light years. They have given you a new idea. Do you know? The nearest star Alpha Centauri is about 1.34 parsec from the sun. Most of the stars visible to the unaided eye in the night sky are within 500 parsec distance from the sun. Okay, we come to know the units which are used to measure very large distances. What about the very small distances? That is of the order of atomic value, because we cannot see even molecule or atom with our naked eye. Then how can we measure the distance between two atoms, distance between molecules? So that are called small distances. To measure small distances such as distance between two atoms in a molecule, size of the nucleus and wavelength etc., we use submultiples of 10. These quantities are measured in angstrom units. So table 1.5 shows you smaller units of meter. 1 Fermi is equal to 10 to the power minus 15 meter. 1 angstrom is equal to 10 to the power minus 10 meter. 1 nanometer is equal to 10 to the power minus 9 meter. 1 micron or micrometer is equal to 10 to the power minus 6 meter. 1 millimeter is equal to 10 to the power minus 3 meter, and 1 centimeter is equal to 10 to the power minus 2 meter. Okay, next we need to see about mass. Mass is the quantity of matter contained in a body. I repeat, mass is the quantity of matter contained in a body. What is the SI unit of mass? SI unit of mass is kilogram. Define the unit of mass. The answer for it is, the SI unit of mass is 1 kilogram, and 1 kilogram is the mass of a particular international prototype cylinder made of platinum iridium alloy kept at the International Bureau of Weight and Measures at Servus, France. There is a place in France named Servus. In that place, they kept a prototype cylinder which is made up of platinum and iridium alloy, and its weight is equal to 1 meter. So they duplicate that weight, and nowadays we are using 1 kilogram in every shops. 1 kilogram means they have a weight known as 1 kilogram. That 1 kilogram is the duplicate of this 1 kilogram which is kept in this Servus, France. Okay, so the unit grams and milligrams are the submultiples of the 10 of the kilogram. Similarly, the quintal and metric tons are the multiples of tens. So here they have given how can you obtain multiples and submultiples of 1 kilogram. Next, atomic mass unit, which is used to measure the mass of microparticles such as proton, neutron and electron. Mass of a proton, neutron and electron can be determined using atomic mass unit, that is known as AMU. One atomic mass unit is equal to 1/12th of the mass of the carbon 12 atom. So mass of 1 ml of water is 1 gram, mass of 1 liter of water is 1 kilogram, mass of the other liquids vary with their density. Okay. Next we need to see about time. Time is a measure of duration of events and the intervals between them. The SI unit of time is second. 1 second is the time required for the light to propagate 29 crore 97 lakh 92,458 meter through vacuum. It is also defined as 1 divided by 86th time 400th part of a mean solar day. Larger unit for measuring time are day, month, year and millennium, etc. 1 millennium is equal to 3.16 in 10 to the power 9 second. I repeat, 1 millennium is equal to 3.16 in 10 to the power 9 second. Next we need to see about temperature. Temperature is the measure of hotness or coldness of a body. SI unit for temperature is Kelvin. 1 Kelvin is the fraction 1 divided by 273.16 of the thermodynamic temperature of the triple point of water. What is triple point of water? The temperature at which saturated water vapor, pure water and melting ice are in equilibrium. So that is triple point of water. At that time the temperature is 1 Kelvin. 0 Kelvin is commonly known as absolute zero. The other units for measuring temperatures are degree Celsius and degree Fahrenheit. Next, unit prefixes. There are some unit prefixes. Unit prefixes are the symbol placed before the symbol of unit to specify the order of magnitude of the quantity. They are useful to express very large and very small quantities. K is the unit prefix in the unit kilometer. A unit prefix stands for a specific positive or negative power of 10. Some unit prefixes are given in table 1.6. Peta means 10 to the power plus 15. Similarly, 10 to the power minus 15 means femto. 10 to the power plus 12 means tera. 10 to the power minus 12 means pico. 10 to the power plus 9 is giga, and 10 to the power minus 9 is nano. 10 to the power plus 6 is mega, and 10 to the power minus 6 is micro. 10 to the power plus 3 is kilo, and 10 to the power minus 3 is milli. 10 to the power plus 2 is hecto, and 10 to the power minus 2 is centi. 10 to the power 1 is deca, that is multiplied by 10. 10 to the power minus 1 is deci, that is divided by 10. So minus value means you have to divide by that number of zeros. Okay. Multiplication means, power means you have to multiply with 10, 100, 1000, etc. The physical quantities vary in different proportion, like from 10 to the power minus 15 meter being the diameter of nucleus to 10 to the power 26 meter being the distance between two stars. And if we consider mass means 9.11 in 10 to the power minus 31 kilogram, which is the mass of the electron, and 2.2 in 10 to the power plus 41 kilogram, which is the mass of the Milky Way galaxy. You couldn't imagine the minor value and the major value. It's very unbelievable, but it is true. Now let's see the rules and conventions for writing SI units and their symbols. See, you need to forget everything whichever you use up to date. இப்போ வரைக்கும் நீங்கள் எப்படி யூஸ் பண்ணிகிட்ருக்கீங்களோ அதை மறந்துடணும். சில மேக்ஸை மறந்துடணும். Sciences, you have to deal science in a different manner. You need not to mix the rules of other things with the scientific rules. Scientific rules are different, and you must follow that scientific rules whenever you you're supposed to write scientific notations. Okay. The first point, the unit named after scientist are not written with a capital initial letter. See the example, Newton, Henry, Ampere, Watt. What your literature taught you, உனக்கு லிட்ரேச்சர் என்ன சொல்லி கொடுத்துருக்கு, ஒரு பேர் எழுதுகிறோம் அப்படின்னா, if it is a proper noun, you should write first letter as a capital letter. But in science, if you mention the full name as a unit, நியூட்டனோட பேரை யூனிட்டாக, நியூட்டன் இஸ் த யூனிட் ஃபார் ஃபோர்ஸ். அப்போ யூனிட்டாக நீ யூஸ் பண்ணுற அப்படின்னா NEWTON, you are going to write the full name as a unit. Okay, you should not write the first letter as a capital letter. நியூட்டனோட நேமை எக்ஸ்பிளைன் பண்ண, if you want to write the history of Newton, you should write Newton in first letter capital. But whenever you use Newton as a unit, you should not write the first letter as capital. Second point, the symbol of the unit named after scientist should be written by the initial capital letter. For suppose, I would like to write the first letter alone, symbol alone. So, I can write capital N alone. Instead of writing the whole name Newton, I can write capital N alone. For Ampere, I can write A alone. For Henry, I can write H alone. Okay. The third point, small letters are used as symbol for units not derived from a proper name. These are all the symbol. Here we have seen a list of symbols. This list of symbols are derived from a proper name, scientist name. There are some symbols which don't have a proper noun. For example, kilogram, kilo, K. So here, most of the time we used to write K capital, G small. This is a wrong notation. You have to write KG, small k and small g. Okay, you should not write the first letter capital for the symbols which is not a proper noun. Fourth one, no full stop or other punctuation mark should be used within or at the end of the symbol. See the example. So you should not use any punctuation mark. Okay. See, this is a wrong one. At the end they have put a full stop. You should not write like this. This is the right one. This is wrong. This is right. Fifth one, the symbols of the unit are not expressed in plural form. We should not write the symbols in plural form. 10, more than one means, in literature in English we learnt that more than one means we should include a plural S. Okay. But here in science you should not write the symbols in plural form. 10 kg, 10 kg alone, 10 kgs you should not write, because if you write 10 kgs, what is the meaning of this one kilogram into second. Okay, kilogram into second leads to some other derived quantity. So it is not a mass. It is a wrong notation. Okay, so you have to write 10 kg alone. You have to write 10 kg alone. Next, sixth one, when temperature is expressed in Kelvin, the degree sign is omitted. So you should not put a degree sign when you write the temperature in Kelvin. This is wrong. But if you express the temperature in Celsius and Fahrenheit, you can write the degree symbol. 100 degree Celsius, 108 degree Fahrenheit. Like that you can put a degree symbol for Celsius and Fahrenheit. The degree symbol is associated with Celsius and Fahrenheit and is not associated with Kelvin. And use of solidus means slash. Use of solidus is recommended for the indication a division of one unit symbol by another unit symbol. Not more than one solidus is used. For example, they have given the example here, meter divided by second. One solidus can be used. More than one means, for example, see this, the second example, joule divided by Kelvin divided by mole. So what is the meaning here? What you want to say is joule divided by Kelvin divided by mole, but it will result to joule mole divided by Kelvin. The symbol will be resulted as joule mole divided by Kelvin, which is a wrong thing. So how can we express two solidus? Two slashes means you can express joule Kelvin power minus 1. Instead of this one, you can put Kelvin power minus 1. Instead of this one, you can put mole power minus 1. So more than one means you can raise the negative power. You can raise the negative power. Joule Kelvin power minus 1, mole power minus 1. The number and the unit should be separated by a space. The number and the unit should be separated by a space. Okay, so you have to put space. Accepted units must be used. Not accepted unit should not be used. See, some electricians may notate as 5 amps means 5 amps AMP, like that they will write. The amps is not a accepted unit. For ampere, you should write fully AMPERE, at least like this, otherwise A, 5A. Okay, you have to write like this. AMP is not a accepted symbol. Another thing, we used to write seconds. 10 seconds means we write 10 sec SEC. This is a wrong notation. How should you write 10 S? Okay, this only correct. The numerical values of physical quantities should be written in scientific form. Example, the density of mercury should be written as 1.36 in 10 to the power 4 kilogram meter power minus 1 and not as 13600 kilogram meter power minus 3. So for the density, the scientific notation should be followed. What is that scientific notation? One whole number corrective. For everything, we try to write one whole number corrective. Okay, so how can we write 1, 2, 3, 4? So 1.36 into 10 to the power 4 kilogram meter power minus 3. Okay, I hope you all will understand up to this rules and conventions for writing SI units and the symbols. Okay, I am going to wind up my today's class up to this. So please go through the video, go through your textbook, read the textbook again and again. You yourself mark 2 marks and 5 marks. See, this rules and conventions for writing essay system is 2 marks. Many one words are there. All the definitions will be asked as a 2 mark. So you find out 2 marks, you raise question as 2 mark and 5 mark, find out the answer, write the question in the book itself and mark the answers in the book itself and learn them. I also give you some homework later in voice message. Okay. All the best, girls. God bless you. Thank you.